I'm Antoine Mottier, OW2 CTO, and in this presentation I will try to explain how the FASTEN project tried to improve dependency management by using a call graph. But first, I'd like to take a step back and try to do a kind of panel of what the current solutions are available related to dependency management, how we do it, and to then present really how we try to improve it. So as you know, when we develop software today, we never start from scratch. We use a lot of libraries. We use feature, of course, of the ecosystem we developed on, but we also use third-party library, most of them being open source. And this leads to some challenge because dependency can be quite simple at start. You might have only a few dependencies declared in your application, but the complexity can grow quickly. For example, in this illustration here, my project have 3 direct dependencies, but those dependencies can have themselves other dependencies. So you have this kind of graph that is building up with what we call transitive dependencies. And to bring a little bit more complexity here, a dependency can be at the same time a direct dependency and transitive dependencies. And you need also to deal with a version of your dependencies. So you might depend on a given version of the dependencies, but another part of your dependency might require a different version. So you can have a conflict. And as I said, the complexity is growing. We have more and more library that we depend on, and themselves have some extra dependency. So we have this huge graph of dependency building up. But what is nice is that we have toolings. We have toolings such as Maven for the Java ecosystem. We have pip for Python with the Python package index, that is a central repository where we can get the files from. And we have equivalent, for example, we can view the Debian packaging system as a way to build application to manage the dependency for the C programming language, for example. I take the example of those 3 languages here because they are the 3 languages that FASTEN support. In my presentation, I will mostly highlight how FASTEN help the Java developer because I'm more familiar with Java, but the same really apply to all different supported language by the project, and it can be extended to support more languages. So one issue we really face when we deal with dependencies is the security. If one of your dependencies have a security issue, it can impact your application. So you need to monitor the security of your dependencies. But as we saw earlier, you also have transitive dependency. And so you need to take a look at those transitive dependencies security issue as well, because they can propagate up to your code, your application code. So that one aspect that you need to be aware of. And you have also similar issue, regarding license. You need to make sure that the different library you are using are compatible with each other, the license are compatible and also compatible with your application. And with this growing graph of dependencies, it can be quite complex. So the first step is probably to limit the number of dependency. You don't want to deal with unneeded dependency. For that, there is already a tool that exists, for example, in the Java ecosystem. It's called depclean, and it will look at the dependency you declare in your project. So for example, here, I declare a dependency on SLF4G library, and I'm using it in my application. So it will be able to find that this is a used dependency. And if I remove this code, if I don't actually use it, it will tell me that I can remove it. The trick is, if I do some specific calls, like dynamic calls that are resolved at runtime, it will trick dep clean tools, and it will not be able to identify that I'm actually using the library. So it'll tell me that the library is potentially unused, and potentially here is very important because you cannot say for sure. So the tool is limited here. We have a limitation. It's only potentially unused. Sorry. So we already see that some limitation exists. We have also another very popular tool that is dependabot. And in the same way, I did a test here, having a dependency on a vulnerable code. But the dependency that was vulnerable was not direct. It was transitive dependencies. And for Java, dependabots don't give me any alerts. So that's an issue. It doesn't cover transitive dependency, only focus on the direct dependency. On the other end, we have Sneak tool that is better as dealing with transitive dependencies. But again, I spot a limitation that if I declare a dependency that I don't use, it's weird, but when you have a lot of dependency, you might include them, but not using them. It's what I have here in my example. And Sneak will tell me that my my project is vulnerable and that I should update my dependency, whereas I don't use it. So the best recommendation would be to tell me to remove it. And the same feedback is given by dependabot or also dependency check, that is another Java tool, Maven tool. So overall, what we see is that, the toolings are lacking accuracy because they work at the package level and they don't look at the code and the actual call of the library. So this is what FASTEN tried to improve. It will not only deal with package dependency, but will try to look at the actual function call, method call within the library. So we have a very basic example here. You can see the different call of the function, and you can see some function are not used. So what we do with that is that we'll enrich this graph with some metadata. We use, for example, data coming from CV central database for the vulnerability. We use license information we can get by analyzing the source code, and so on. And we enrich the call graph we built of all the function call with some extra information. This will help us then to provide the developer with additional information and more accurate information. So basically, when you build your project, for example, here with Maven, it will resolve the dependencies. And then FASTEN will act as an extension. It will be actually integrated as a Maven plugin. So it's really on top of the existing dependency management tool. And it will build the call graph for your code, so for your application code. And it will be able to get the graph for your dependency from the Maven central repository. This is to improve performance. Publicly available library are processed by a central server, a FASTEN central server, or it can be your own if you want. You can install it on premises. And it will then stitch together all the call graph, so the one from your application, the one for all the dependency, to have this global view of all the calls being made inside your application. And it will enrich them with the metadata, so like CV, license information, and so on. And then it will be able to notify you only of the call to vulnerable code that are actually made in your application. So if the vulnerability lies in a part of the library you don't use, it will not tell you that you need to upgrade. It will only tell you to upgrade if you are actually calling the vulnerable code. So in this way, it will be more accurate compared to tools like Dependabot or Snyk that currently work only at package level. So we go one step down and look at the source code. So the big challenge here is to build this. So there are still a lot of work in progress in this area to make sure that we built an accurate call graph and to be able to identify all the dynamic function call and so on. So that was really a quick introduction of FASTEN. I just want to say a few words. Also, we are actually developing this project as a European funded project, and we have a consortium of various partners. You can see the full list here. So it's some universities, some companies, some non-profit organization like OW2, and we collaborate all to build these tools that will work on top of the existing dependency management tooling. So thank you for your attention. If you have any question, I can take them now. Or also, if you are interested to learn more, you can, of course, visit the website. Also forgot to mention, but of course, it is an open source project, and all the source code is available currently on GitHub, so you can take a look there, and you can follow us, of course, on social media to get more news. Thank you very much for your attention, and now if there is any, I can take questions.
Hi there, thank you for the presentation. I might not have been here to hear it, but does FASTEN work with other package managers too, practically? Like NPM?
Yeah, it's not a problem.
But it's just tooling, so there has to be, is there an implementation already written for NPM, for example?
So the question is about which package managers does FASTEN work with?
Yes.
Yes, so actually right now we support Maven, we support pip for Python, and we work with the Debian APT tool, and there is no currently support for NPM, for example, but the framework is really designed to be extendable, so it should be doable. It's not part of the project right now, but we are really open to contribution, and so such implementation can be added. I would not say it's easy, but it can be included in the project.
Okay. Thank you very much.